हाँ.
Hello students, today we are going to perform an experiment which is to determine the shear parameters of a soil by direct shear test. So for this we need a cohesionless soil of fixed quantity. If we know the density of the soil, then we have this shear box apparatus, and at the bottom we place this graded plate. As you can see, we are putting this plate here. We have this plate. So on the top of it we will place these two plates, which is a graded plate also, and this one is perforated plate. So we will place it like this, and then on the top of it we are going to place this. And again, now what we will do is we will take a soil sample. If the density of this sample is known, so the dimensions of this shear box we already know that this is 6 centimeter, and the height and the length and the breadth of this is 6 by 6 centimeter, and we can fix the height of this shear box apparatus, and by filling the soil sample, the cohesionless soil, which is sand we have taken. So when we will fill this soil into this shear box apparatus, then on the top of it we place these two plates which perpendicular to the loading direction. If the load is applied in this direction, then this is the parallel, these plates are parallel, so we will put this in perpendicular direction after filling this soil. So we will put it like this. Then on the top of it, this is the loading pan. This loading will be done, and we will place a ball here to which provides the centric loading to this, and we will put this whole assembly into a box, and then we will perform our direct shear test. Basically, it is used to calculate two parameters. The one parameter is angle of internal friction, other is the cohesion angle. So using this direct shear test, we will calculate the shear parameters, which is C and phi. So now we will start. We have already taken a sample of approximately 180 gram. So we will fill this sample into this shear box, and then we will perform the test. So this is how we are going to put the whole assembly together, and this is the soil we have taken, and two plates we have placed at the bottom of this box, and we have placed these two pins so that this will not move till we place this box in that box. Okay, now we are going to fill the sample into this box. So we have approximately 180 gram of soil, this sand. Now we have, as you can see that we have placed this now we will place these two plates on the top portion of this soil, and we will place these two plates perpendicular to the loading direction, as you can see. And now we will put this load where we are going to put the load at the top. So we will little compress this, and now this whole assembly is complete. So now we are going to put this whole assembly into the shear box test apparatus. So this is our shear box test apparatus, and now we are going to put this here. From this we are going to put this normal shear load, and so this will now we will put this on top of this as you can see that we have placed. So this will from this we will apply the normal stress on the the specimen, and we have to fix the normal stress what we are going to put. So as you can see, there are 3 screws here. So this one, this is 2, and this is 3. These screws are provided so that when we tighten the screw, the gap between these 2 plates can increase and less friction will be provided. And these as you can see, there are 2 screws also. So now first we will tighten these screws so that gap will be there between the 2 plates and less friction will be applied. As you have seen that we have removed these 2 blocks which holds these 2 plates together. Now as you can now I will show you the other parts of this. So from here we are going to apply the normal stresses on this, and this is the gearbox from which we can change the gear of this, and from this we can change the this speed of this. This is A shows that 1.25 mm per minute deformation will be applied on this sample. So we have placed this on first gear, and there we have 2 LVDTs for this is the one LVDT for calculating the horizontal this deflection in the this shear box. And this is generally we do not use this and this the use of this is to calculate if there is any vertical deformation in the sample. Okay, so we have the whole assembly, and this is the data logger, and which we will note down the readings of this, means the load which is applied on the shear box apparatus and the deformation which is applied on the. Now we will tear this and we will bring it to 0. Now we will provide 0.2 kg per centimeter square load on this, and this is known as the normal load which we are going to apply. As you can see that this is a screw which is given, and we have already tightened this so that the direct load when we have applied this, direct load will not be applied to the soil sample. So now we will going to loose this, and then we will switch on this machine. So as you can see, then there is a gap. So now we have removed the 2 screws. Just keep in mind that before doing the experiment you have to remove these 2 screws. And now we are going to perform an experiment, and we have already teared this to 0. As you can see that this is 0 load. One is showing the load and other is showing the horizontal displacement. So now we are going to perform the experiment. So we will switch on this, and as you can see that the readings are of this are changing. Load is applying and deformation is also there. So we will note down the maximum displacement and the maximum load which is applied to this sample. That will be our shear stress. When we will divide it by the area, load divided by the area, then that will be our shear stress. So it is increasing. As you can see, the load is applying on this. When load is applied from this point and this part remains constant, and this box starts moving and the lower plate moves. So as again you can see that this is still increasing. At one point will come when it will not further increase, and the maximum load that we will take that as a maximum load, and it will start decreasing afterwards. So now the maximum load is 5. load is still applying, but the displacement is increasing, but the load is not increasing. If it will increase after 5, then we will note down, otherwise we will take that as a final load, and I think it is going to decrease, so we will take 5 as our final load, and we will divide it by the area, so that the shear stress will be calculated from that. So it is increasing, so that will be our final load. And now we are going to switch off this, and then for the next step we are going to apply 0.2 into 2 means 0.4 kilonewton, that kg per centimeter square load. Now we are removing the load, and by tightening this, now we will remove this sample from the shear box apparatus, and then now we will again refill this, and then we will again perform this experiment in the same way that we have just performed. So this is basically the load cell which shows the reading, how much load is applied. So now we are going to take the sample out, and we will again fill the sample in the similar manner that we have earlier done. Now we will remove all the plates, and we will remove all the sample from this. We will take this again and perform the test in similar way. How much soil we have to take, this depends on the density in which we want to perform. If we want to perform in the higher density, then we have to take the sample, weight of the sample more. And now we are going to put these two plates back into this. So we are again going to put this sample into the box. So this is how we are going to apply the load cell into this. We will tighten this so that whenever a small increase in load is there, so it will note down the small increase in the load. So before doing that, we will again tighten this and remove these two screws. Now we will again put this assembly into this, and now again we are going to apply a normal stress of, earlier it was 0.2 kilonewton kilogram per centimeter square. Now we will increase this to 0.4 kilogram per centimeter square. So this is 0.2 kilogram per centimeter square, and this is 0.1 kg per centimeter square, and these two are 0.05 kg per centimeter square. On the whole, it is total of 0.4 kg per centimeter square. So everything is again at its position. So again we have to tear this, and we have fixed this at 0 again. So using this tear, and then we press enter, then we can tear this to 0. So we have teared this. Now we can start performing the experiment again. So we'll switch this on again in the forward direction. There are two directions. So we will switch on this. As you can see that the load is increasing in this also. So but we have applied more normal stress. So in this we can see that we expect more shear stresses. This and load is increasing, and it is higher than the previous one. So let's check how much where it goes, and it is around, it is increasing. So we will wait till the maximum load 6.7 was the maximum load that it has shown. So we'll wait if it shows more than 6.7, or and otherwise we'll take this as the final load. Whenever it starts decreasing, the failure of soil occurs, and that load will be the final load, and it has already started decreasing. So 6.7 will be the final load. So now we will switch off this. We are repeating the same procedure for the third time. So now we are going to apply 0.6 kg per centimeter square, and this is 0.5 kg per centimeter square. So it has already taken a support of this, so no load will be applied while applying the load on this sample. So now we are going to lose this. And these two screws will be removed, and we will tighten this first, then we will remove these two. Now again we have all the things at their place. So now we are going to switch on this again, and this is 0 and it is increasing. As you can see that it is increasing, so probably this will go higher than the previous load. So let's see what the highest load it takes.
करो